Hello and welcome to part 2 of this particular lesson. We're talking about prisms, a surface area of prisms and cylinders. We talked about surface area of prisms in the last one. Remember, a prism is a three-dimensional object whose bases are congruent. It follows pretty much the same concept it as a cylinder, except a cylinder does not have rough edges. For instance, a rectangular prism has rough edges. We see corners here, right? A cylinder, it's kind of like if you think of a paper towel, cylinder is a three-dimensional object whose bases are congruent circles. Now, I did mention a cylinder. Think of it like a paper towel, right? When you unwrap, or like a water bottle, or a pop can. Now, if you have, for instance, I'm going to do this a dotted because you cannot see that part. Anything you can't see, we put in a dotted line. Now, if you think of a paper towel, you unravel a paper towel, right? And you unravel it. And let's say you cut it, right? The moment you cut it off, you could actually lay it flat. And what does that actually turn into? Well, they turn into rectangles. So if you think of the outer part, the lateral area of a cylinder, and you lay it flat, like a net, right? We talked about nets in our last one. That means we would have a rectangle for the lateral area. The bases, however, are circular. So that means we would have a circle on the bottom and a circle on the top. You could even stack these on top of each other if you really, really wanted to. It doesn't quite matter where you put it because no matter what, this would translate back into a cylinder if we put it all together. So this is what it would look like as if it was a net, if we actually flattened everything out. Now, the nice part about this is it follows the same general idea for a rectangular prism. If you remember, our surface area equation for a prism is lateral area plus 2 times the base. Well, in this particular case, we could do the same thing. We could actually solve for the lateral area of this, which is, in order to find the lateral area, we just need to take the perimeter of the base times the altitude. In this particular case, the perimeter of the base is actually a circle, which is, if you know, the perimeter of a circle is actually just the circumference. So can we solve for the circumference? So we need the lateral area of a cylinder, which we know is the circumference. And if you remember the area equation for, or not the equation for a circumference, not the area, then that is equal to one of two equations, 2 times pi r or pi times diameter. So as long as you know the radius or as long as you know the diameter, you could actually do these problems. And then to find the lateral area, its circumference, I probably should have done this a little bit differently. Probably should have moved this here. Circumference times altitude. Okay, so labeling this out. Not erase this all because we don't need this anymore. Here you go. So we could keep the net there just so we could visualize that. Here, I'm going to highlight this. Ooh, let's use purple just like we did last time. We have our 2 bases. Okay, and then here, I'm going to highlight this as well. This is going to be our surface area, our lateral area. Okay, so I'm going to label this. We have base 1. We have another base 2. And then we have the lateral area. So the lateral area is the circumference times, let's actually draw radius. So 2 pi r, or pi times diameter, times the altitude, lateral area. And we could call this, once again, we could call this the altitude. Okay? So the height, but I'm going to call it altitude. So let's give some actual values to this. Okay? So solving for the lateral area, lateral area of the cylinder is circumference times altitude. The surface area of a cylinder is equal to lateral area plus 2 times the base. Isn't that the same equation we just had here? Well, it is, because it follows the exact same concept. If you find the lateral area of a rectangular prism, then you just add on the 2 bases to it. The same thing here. If you could find the lateral area, which is this rectangle, if you could find that lateral area, solve for it, and then add on the 2 bases, then you have your total surface area. Okay, and let's actually plug in some values here just so we have an example. So these are 2 equations that we need. Okay, let's pretend our radius here is equal to 5 centimeters. And let's say the altitude here is going to be equal to 10 centimeters. Then we could actually do this. Let's start with the circumference and the lateral area. So here we would take a circumference, which is 2 times pi times 5. And put the 5 in parentheses to imply multiplication. And then multiply this with the altitude of 10. So 2 times 5 is 10. 10 times pi times 10, which is then equal to 100 pi. And now we have the lateral area. So lateral area is equal to 100 pi centimeters squared. Now the base on the other hand is, we need to know area is equal to, of a circle, pi r squared. So here we do that. 2 times the base would be equal to 2 times pi times 5 squared. 5 squared we know is 25. 25 times 2 would then be equal to 50. So we do 50 pi. And then we just add these together. So we have our 2 pi and our 2 base and our lateral area. And we could add these together as so. 100 pi centimeters squared. Sorry, there it is. Plus, this is also centimeters squared. 50 centimeters squared. And I forgot the pi. 50 pi, I forgot it again, centimeters squared. You could add these two because they are both in terms of pi. So we end up with 150 pi centimeters squared. And that would be the surface area, or also known as the total area. So cylinders follow the exact same concept as rectangular prisms, except the base is now no longer something with rigid edges. It is a circle. And the perimeter of a circle is just the circumference. And we know how to solve for the area of a circle because we did it in our last unit. So this should hopefully be a piece of cake, especially if we understand this concept of the lateral area and surface area of a rectangular prism. Okay? All right. That's it for today. If you do have any questions, please ask, and I'll see you in the next one. Bye.